Hi, folks. Matthew Lanigan here again with BayWa RE. I'm the Chief Commercial Officer here with BayWa. Really appreciate you taking the time to be with us and our great partner Fronius and learn a little bit more about their new Gen24 product. Before we get going, I just want to let you know that this will be recorded. It will be up on our YouTube channel. If you haven't signed up for our YouTube channel, we'd really love it if you did. You can find this presentation as well as all our past recordings as well. It'll also get included with your monthly newsletter. We will be taking questions. We'll answer them as we go. If you wouldn't mind, you'll see there's a question box in the bottom right corner. I was just hoping somebody could test, and somebody knows me well and has already tested for me, so that's great. Continuing education is a core value here at BayWa, so we're really happy to extend that to our customer base and for you to join us for this. So without further ado, I'd like to introduce Harsha, who's tech support and guru for Fronius Canada.
Thank you, Matt. Hello, everybody. My name's Harsha, and I work as the tech support manager for Fronius here at Canada, and have been in this position for close to 7 years now. So I do have a background in electrical engineering and renewable energy, and I use that to support all of you across this endeavor. Now, without further ado, let's get started. And so we are today presenting to you the next version of the Fronius product that we have now available on the market. We call that the Fronius Gen24. So these happen to be a part of the evolution of our product line. So previously we did not have, what should I say, something exclusively made which is storage capable, whereas this inverter now fills that void for us, all right? And so now Fronius, just making sure everybody can still see my screen. I trust they do. Okay. Now Fronius is and was a family-owned business, and we are based out of Austria, although the Canadian subsidiary is entirely Canadian. And one of the visions of Fronius is 24 hours of sun, which basically means that we truly believe that all of our energy needs can be met through whatever you can get off of renewable sources like solar or wind, and especially if you are able to combine that with storage, and that is kind of what is illustrated in this little pictogram that you see here. Now, a lot of this ties into how you manage the energy, and so we also always ensure that all of our products are smart grid ready so that they can be incorporated into your home energy management system with a view of fulfilling the 24 hours of sun phrase that we have, because how you manage your energy will also take you a long way towards meeting all of your energy requirements should they be heavily dependent on renewable energy sources, which tend to be intermittent, right? So now getting into the actual product itself, the product was basically made, taking into account the sort of feedback.
Harsha,
Yep.
but could you just hit the presenter mode so that it goes full screen, please?
Okay. Give me a second. My apologies. Does that show up now?
Yep, that works there. Thank you.
Okay, sorry about that, folks.
Nope,
and
great.
so, yeah, thanks, Matt. So coming back to this, if it wasn't clear, I hope it is now. So this is basically what we believe, which is basically learn how to manage your energy. And if you do, especially with the incorporation of storage, you can meet most, if not all, of your energy requirements through the power of the sun. Now, the product itself was built taking into account feedback from our customers and our experience across different subsidiaries across the world, because Fronius is present in a whole lot of countries across the world. And so some of the things that we did receive in terms of feedback from our customers was most people were looking for something that is simple and fast to install. It is flexible should you need to make any changes in the future. And if you do need to make your product future ready, which is basically, in the event that you build your system now and a couple of years from now or a couple of months after the installation, you decide that you would benefit by using storage, the same product through a firmware upgrade only, because it already comes with the hardware built in, can be changed into a hybrid system, which is capable of working with batteries as well. And so another feature that was commonly requested is to make sure your system is lean, because it is very common in the market to see a lot of other manufacturers with very fancy bells and whistles, but oftentimes most people tend not to use them or know or aren't aware or informed enough on how to use them. So that is towards making sure that the system itself is lean, and then to also ensure that you get as much as possible out of your system, given that these typically tend to be used as grid-tied inverters, and a grid-tied inverter's main job is to basically extract as much energy as possible from the PV array and basically dump it on the grid. Now, in the event that you do have local consumption, obviously that consumption will be met first, and over and beyond whatever you have consumed, if you do have any excess, that will go back to the grid. And in this process, the idea is for you to go with storage, you can also count on being energy independent in the event that you were to have any sort of outage, etc. So your system should be able to tide you through, but that is more a function of the hybrid version of the same inverter. Now, this is an actual picture of what the product looks like. So we call it the Fronius GEN24. And all of the features that I did describe or talk about till now are incorporated into this product itself. Okay. Now, the heart of your PV system is basically the inverter, and that didn't mean that the rest of the system should be ignored, because the inverter is one part of a big system, and the BOS, which is short for balance of system, comprises the PV array, your cabling, etc., all the other accessories which are required by the inverter to basically function as an actual inverter, right? And we ensure, or rather we support you through all of the various steps of designing a PV system and the installation as well, because if you did not understand how to design or make use of the various features on the system, you would likely be not utilizing the inverter or the system to its full capacity. Now, the Fronius GEN24 inverter is a single-phase inverter that is capable of working on a 208 grid or a 240 grid. Both of those could be, used depending on where you are. And these come in different power classes or capacities. So we have them starting from 3.8 kilowatts, 5 kilowatts, 6 kilowatts, 7.7, and 10 kilowatts. Okay. Remember, all of these are single-phase, power classes of the same device. The device itself has two MPP trackers, that is 2 MPPT, and we have 2 connections per MPPT. So which means that you have 4 connections, and so depending on the short circuit current of the PV module you choose, you could likely use up to 4 strings with this inverter. Now, what are the actual features and strengths of the product itself? So one of the biggest strengths, or rather we like to say, is our strength is our support. And we support you through different platforms, through multiple different ways. It could be through any of the digital self-help tools, be it for commissioning, designing your system, troubleshooting your system, or creating a ticket or call it in. This isn't to take away from the actual in-person support that you will receive from us. So we are always here. We are Canadian. We are based out of Canada. We understand Canadian climates, Canadian customers, Canadian utilities, and Canadian use case scenarios as well. Now, with regards to the installation of the actual inverter itself, we have had extensive feedback from the field, and we understand what are the common pitfalls and drawbacks and what are our pluses and minuses, and we've gathered all of that and incorporated that into the design of the system. So we have had situations, and I'm sure most of you who have used Fronius inverters in the recent past understand that the device has very strict torque requirements on the screws, and despite all of that information and making sure that the customers are aware, we did still receive some issues there. So what we did was we basically did away with screws, in the sense, these are not per se screws, but these are what we call twist nuts. So which basically means that were you to give your screw a half turn, 180 degree, it's closed, as in it's secured, and you do the same thing in the opposite direction, you give it a half turn, you've basically opened the screw. So please keep that in mind when you're using the device, because these are not per se your regular screws. So you do not want to be using any sort of power tools or drills, etc., because these are only one half turn. So if you're getting the inverter out of the box, it's already secured. So you do in a counterclockwise direction, one half turn, it'll release the screw. So the cover itself will have about 6 to 8 screws. And so if you were to do the one half turn in the counterclockwise direction, you will literally loosen the cover. So the same holds for everything else there. The inverter itself is very light. And it is a little different compared to what it was before, in the sense the previous generation of inverters, which we call snap inverters, had the wiring on a separate mounting bracket behind the inverter. We've done away with that concept. The wiring now is actually going into the little plugs that you can see, which are in the gentleman's hand on the left side. So those are catch releases. So if you pull the plastic orange tab up, it releases a catch underneath. You would basically skin your wire to the appropriate length, and then you would insert the skin portion into that release there. And if we were to let go of the orange tab, it'll basically engage and prevent you from pulling the wire out. Now, the catch releases themselves that you see are on those white terminal blocks. The terminal blocks can be completely unplugged from the receiving insert onto it. Okay, so it makes the installation really quick and easy, because for your wire terminations, there are no screws. The housing cover, the little cover which you would take off to release that little connection compartment, all of those are just 180-degree twist turns, so there's no screws on that either.
Harsha, we have a quick question here.
Mhm.
208-volt version, is it three-phase or single, i.e. in
Single
sets of
phase.
3?
It's single phase. So
Okay.
think of it this way: if you were to have a 208 delta connection, you got 3 208 connections. So you could potentially throw 3 single phase inverters on each of those phases, if you could, as
Great.
long as you take into account loss of phase. Okay.
Thank you.
All right, thanks, Ben. So now coming back to a part of the support. So there's lots of different support options. Now, one common thing a lot of people will like to do is always to use a third-party simulation tool when they are trying to make your calculations for your string design. That's all nice and good, but we always recommend that you still run that design through the Fronius device design tool, which we call the Fronius Solar Creator, because anytime you use a third-party tool, third-party tools tend to be manufacturer agnostic. So any sort of device constraints or limitations are not reflected in your third-party tool. So you may get a string design which could look feasible via the third party's point of view, except it might not be taking into account other limitations which would have, which are built into the creator tool. So if you have not used the creator tool, we can always support you through that. We do have webinars, etc. It is fairly intuitive, but if you aren't sure, you could always sign up for the webinars. Outside of that, once you have designed your system, your cabling, etc., you got them all installed and connected to the inverter, the next step of the process is going to be the commissioning process. So the commissioning process, we have an app. It's called the Fronius Solar.start app. So basically, you would download the app. The app's free again. And so basically, you would run through the app. And if you have commissioned any Fronius inverters in the past, you will be aware that the inverters in the past did have a display, and there used to be buttons underneath the display, and so you would basically commission the inverter by pushing those keys, and for feedback you would see what's going on through the display. Now, the new generation of inverters, there are no displays, so what we are counting on is some sort of a smart device. It could be a tablet, a smartphone, or a laptop. So you would every inverter now will have what we call a pilot. In the previous version of inverters, you understand that not all inverters needed data manager cards. That concept doesn't carry through now. Now every inverter has its own pilot. And so what you would do is on the inverter's main face of it, there is a little LED kind of thing in the middle. So where you to gently place your thumb for a few seconds and take it away, you activate the inverter's Wi-Fi access point. You will connect to that with your smart device, and then you will run through the Fronius Solar.start app so as to commission the inverter. Okay, so that's as far as getting the inverter to make you power. The next step of the process would be to get this hooked up to an online monitoring service. Our monitoring service is called Fronius Solar.web or Fronius SolarWeb. The service itself is free as long as you have your own source of internet, which could either be wired or wireless. And so once you have commissioned your inverter to make you power, the next step of the process would be to commission your inverter as a part of the same process here to get it hooked up to your internet and then tie it into your SolarWeb account so you can see what's going on with your system. And were your system to experience any errors, you can have them show up on the monitoring platform and also delivered via email to whoever would be tasked with the upkeep and general maintenance of that system. Now, that's as far as getting your system hooked up, commissioned, and you're observing the monitoring. Now, let's assume that there were problems with your system. What should you do? So typical approach is to call it into the manufacturer, or you'd write to us via email, etc. We also have other options. We also have what is called Fronius Solar Online Support, which is short, SOS for short. And so it's the same sign-in as your monitoring account sign-in. So you would sign into this app. It's something you can download onto your phone. You can also access this through a browser page if you choose not to use the app. And so it is geared towards being a self-help tool to be able to troubleshoot or debug anything. And now in the event that you weren't able to fix it yourself, or you didn't get much or out of it, what you could also do is the same app has the option for you to start a ticket so that it comes to us. So you can contact Fronius support via the SOS app and generate an automatic ticket. So that comes to us. And if you aren't again familiar with that, or you're apprehensive as to you have no idea how it works, we do conduct webinars for that. You could always attend any of those webinars. Now, in addition to that, we also have what we call a repowering tool. This is not per se specifically geared for the Gen24, but it's geared for every Fronius product. The reason we came up with that tool was oftentimes you will also find out that people are pulling out an older inverter on an existing array. Maybe it's been out there in the field for 10 years, and you are now trying to put a new Fronius inverter in place there. Except given how old that system is, and how quickly technology changes when it comes to electronics manufacturing, it is quite possible that it may not be directly compatible. And so how do you ensure that it is or isn't compatible, and whether what you are doing is actually right, is via the Fronius repowering tool. And so you always want to make sure you understand the difference in technology and the impact of that difference on the inverter. And because oftentimes you'll also find out that maybe your older array was strung for a different voltage, on the DC side that is, and the new inverter that you're trying to put in there may not exactly overlap with that DC side voltage. And so although it might not per se harm the inverter, you probably will end up not getting enough power out of it, or it might not match your expectations. So you want to make sure that you are not in such a situation, which is why you always want to make sure that you are using the repowering tool. If you're not sure how to use the repowering tool, again, we do conduct webinars and trainings for that. And if you've got more questions about it, you could always reach out to us. Okay, so the idea being your device or your product is only as useful as your information and support regarding that product, and to ensure that you are fully supported through the entire process, from the design, the specification, the building, the commissioning, setting up the monitoring, and making sure you understand how to troubleshoot. We are always here. We've got different means of supporting you in addition to being available on the phone. Now, this is what the Solar Start app would look like. And so again, we've got both versions of it. So you just want to make sure that you download the appropriate version via the Play Store. Okay, and then once you do that, you've got the inverter up and running, and then you activate the WAF access point. And if you remember how to activate the WAF access point, the older inverters, you had to go through the display. The new inverters don't have a display, except there is a sensor on the front. Just placing your finger across that for a few seconds will activate that. And then you connect to it and you run the app. Now let's assume that you've finished the commissioning process. You've also been successful in commissioning the communication side of the system, and you've got it all set up, hooked up to the monitoring, and you are seeing your system online. Now, once you see the system online, a lot of people assume that monitoring is just fancy bells and whistles to do a neighborhood or a homeowners association show and tell to your neighbors. That's actually not the true purpose of a monitoring system, because electricity is what we consider an invisible resource, in the sense that it's everywhere around you, except the only time people actually sit back and take notice is when the power goes out. So that's how much we take electricity for granted. Now, that if you were connected to the utility in the traditional power grid, your power almost entirely comes from the utility side. And given how robust our power systems are in North America, and more so in Canada, you would rarely ever experience an outage. But that need not always be the case, given whatever is happening with the climate. Maybe you're in an area where something happened, or maybe you had a truck run into a power pole and take the line down. So in all of those situations, you will now realize that your backup from your system is where all of this starts counting. And now you'll also realize that anything that you took for granted, vis-a-vis the upkeep of the system, etc., all of that will start showing up when you actually need the power. Now, why am I giving you such a long roundabout story about this? The reason being that all of this, basically your system maintenance, system performance, system behavior, what's going on with your system, it's more almost like a health monitor. All of that is basically available through online monitoring. Now, given that most homes now will almost always have a Wi-Fi connection, your inverter already has the ability to hook on to said Wi-Fi connection. The only condition being that your Wi-Fi needs to be at the 2.4 gigahertz frequency. As long as you can ensure that, you set up the system online, the monitoring platform itself is available for free, and it gives you a great deal of information, in great detail. Okay, and it's very intuitive. So if you're not sure, you could always ask us. We do conduct webinars there. So the basic function of this monitoring system is to let you know what's going on with the system. And given that pretty much all of your solar panels are up there in facing the sun, and getting exposed to all extremes of weather and climates, it is possible that the weather does a number on your system. And if it did, how would you know? If you didn't have monitoring, the only time you would know is perhaps if you did have a net metering contract with the utility and you don't get your check that month from hydro, or your utility, that is. It's only then you realize something's up. Whereas if you did have monitoring, you will know, and you've set it up the right way, you will know very early on, pretty much the same day or even the same instant, that something's going on with your system. And so that is how you would do remedial maintenance on your system, if you understand there's something going on it. If you don't understand, you could either call it in or contact your installer. But the value in the monitoring side of this business is to let you know what's going on so that you can act upon it without too much delay, because depending on what's happening with your system, it might be a more expensive fix should you discover the issue a month later than upfront. And it could just be a much simpler fix if you discovered it early on. Now, in terms of service itself, if you have worked with Fronius, you will also understand that the way products get designed at Fronius is to make sure that they are easy to swap out with very little downtime. And so here, for example, I just told you about how you per se don't really need to unhook your wires because the entire plug comes off that socket. Okay, so assume that maybe you need to have your inverter replaced for whatever reason. And so you call it in, we process an exchange, you get the RMA inverter, you're really not going to redo your wiring. That's the intention. All right, because depending on how your inverter is built, so you may or may not have to redo all of your wiring in both the AC and the DC sides. All Fronius products are built with a view to keep that to the bare minimum. Okay, so you have easy access, easy to switch it out, and better yet, you could basically initiate the RMA process through the Solar SOS app, which I told you earlier was for troubleshooting, but you could also get your own ticket started there. Okay, now in terms of making the device future-proof, that's a little hyperbole, but I would put it this way, very future compliant, if you will. So what I mean by that is we all understand technology is constantly changing, right? And anytime you make a device, the way you make the device decides whether that is going to be adaptable to future technology or not. And this is kind of where I was trying to tell you earlier on, that the device that you buy now already has the hardware on it to make it compatible with storage. So you buy the inverter, and you buy it as a regular grid-tied inverter, but it's already got the added hardware in it. And maybe when you built the system out at the outset, you weren't really thinking about making it into a hybrid system, but maybe your utility rates went up, or maybe the market structure changed when it came to the utility pricing and the tiers, etc. Or maybe they decided that global adjustment is going to be a bigger part of your utility bill in future. So you basically start realizing that the price of storage vis-a-vis the price of the actual your utility bill, the electricity itself, is deciding, or rather is going to decide whether you will look at storage more favorably. And if you do decide to go the storage route, then you can basically pay a fee to upgrade the same hardware with a firmware download from Fronius, which will then turn your device into a hybrid. But do keep in mind that you still have to purchase your batteries. And our compatibility with batteries is basically for the BYD batteries. So these would be the high voltage batteries. So this is basically saying that you bought the hardware now, and without too much of a change on your system, merely through a firmware update, a paid firmware update, of course, it's not for free, you could change the same system into a hybrid system. Okay, so this is what we call the GEN24 Plus. Okay, and so you're not really changing anything out, you're just only upgrading the firmware, which is why we call it flexible retrofitting of battery for full backup power function. So what that means is once you decide you want to go storage, you got your battery and you upgraded the firmware on the device, and were you to have an outage, etc., you can get full backup from that device via that battery. Now, supposing you didn't have a battery, etc., or maybe your battery is completely discharged, but you have sunlight and the utility connection has not yet come back, there is also the option of what we call the PV point. So you can get, what should I say, without any battery, in the sense your battery is basically died out, or you've run out of the charge on the battery. As long as you got sunlight, you can still get a portion of the power available as output from the inverter via the PV point to ensure any critical loads are continuously fed. Okay. Now, with regards to the features of the inverter itself, one common refrain that most times you get to hear as a string inverter manufacturer is, what do you do about shading? Now, shading isn't as cut and dry a topic as most people would make it out to be, because when we say shade, there's a few different types of shade, like in the sense, depending on how far the object casting the shadow is from the PV array, it might cast an actual shadow on the array, or it could just cause a sort of weak shadow. It's kind of, if you were to look at it from the physical or the technical side of it, it's called the umbra and the penumbra. The umbra is absolutely no light is getting through in that region. The penumbra is kind of like a diffused state where you do get some light of it. Now, the reason I'm mentioning all of that here is it's not like if you did have a shadow across a portion of the array that the output of the array is zero. That's incorrect. The inverter will, what should I say, change the way it tracks the maximum power point and still ensure that you don't stand to lose the entire string or the entire array. And how that is achieved is through what we call the dynamic peak manager, which is basically an advanced algorithm whose job is to track the maximum power point, because the maximum power point is basically what, if you were to look at the current and the voltage characteristics of a PV array or a PV module, take for example just one PV module, you will see that your cut sheet or your data sheet for the that particular PV module will show you a curve, and the knee of the curve is basically where you get the maximum power. And the job of the inverter is to ensure that you are almost always operating exactly at the knee of the curve. Now, that is for one PV module. Were you to string a series of such PV modules up in a string, then it's going to be the knee of the curve for the entire string. Similarly, the knee of the curve for the entire MPPT. And since you have two MPPTs, it's going to be two separate curves there. And the inverter will periodically sweep across the PV array, because we understand that the light hitting the panels is a function of the sun moving across the sky. And as the sun moves across the sky, the angle is going to change, which means that the maximum power point of the PV array is also going to keep changing. Now throw in addition to the sun moving across the sky, clouds, debris falling on the PV modules, shadows cast by trees, adjacent buildings. You've got a church spire, you've got a smokestack, you got an air conditioning unit or whatever. All of these things cast shadows across the PV array. And these shadows, because the sun is moving, will also move, which means that the maximum power point on the PV array is moving all the time. And the inverter's job is to make sure that you are playing catch and are sitting at the maximum power point all the time. How does this happen? Through the dynamic peak manager. So you always want to make sure that you understand how that works so that you can get the most out of it. And why am I talking so much about this? Then people will come back to you and ask you, oh, can I throw on an optimizer? So what we are trying to tell you here is the inverter is already capable of doing the very same thing for you. So unless you're in a very strange situation where you're completely buried under snow or something like so, then maybe your optimizer might help you. But you per se don't design your system to be buried under snow. If you are, then the way you are looking at the design probably needs to be reevaluated.
Harsha, we do have a couple of questions here.
Yep, go ahead.
One, will the inverter charge the batteries when the grid is down?
Yes.
Okay. And another one here, once the GEN24 Plus is available, will that be the standard SKU, or will there be two? Or
there
will
be two SKUs?
There'll be two SKUs.
Yeah.
Okay.
Okay. So now coming back to the maximum power point tracking, which is MPPT for short, the Fronius advanced algorithm is going to be dynamic peak manager. Okay, and when we talk about this, like commonly used, what should I say, selling technique in the market is a single leaf will kill the entire string or the entire array even, which is not exactly true, simply because if you did have a leaf, and assuming against a regular leaf, not one of the palm trees, like 10 feet across, so that whatever is shaded is usually adjusted for in different ways. One of the most common things would be the use of bypass diodes, and pretty much most PV modules are built with bypass diodes, which account for a good level of adjustment for shading. The second thing is the inverter uses the advanced dynamic peak manager algorithm, which is doing a very good job of basically mitigating any sort of shading issues. Because even if you were to go with an optimizer, you have to remember that the optimizer isn't exactly making light penetrate that leaf. The leaf is the leaf, it is going to cast a shadow. What the optimizer is doing is basically ensuring that you do not suffer any sort of compromise from all of the other adjacent cells on the same PV module because of one particular area being shaded, which is exactly what even the dynamic peak manager algorithm also does. Okay, this is just a little bit more in detail about that. So if you look at the blue curve is with absolutely no shading. And when you have the blue curve, and again, this is the power versus voltage, whereas your cut sheet from the PV module manufacturer gives you both plots of current versus voltage and power versus voltage. The current versus voltage curve is going to be that sort of knee curve that I was telling you about, made for different temperatures and different radiation levels, intensities. This is the power versus voltage. And so if you were not to have any shading, the flat knee curve corresponds to the big blue curve that you see here. And that big blue curve here with no shading has only one maximum power point, which is called the global maximum power point. And the inverter's job is to make sure it is operating the PV array at the global maximum power point. Now, for the same PV array, were you to have any sort of shading issues, depending on the way it is being shaded, you can potentially have multiple different maximum power points. And the inverter is supposed to sweep through all of those different maximum power points, make a comparison as to which of these power points gets you the most power, and it is supposed to sit there. For example, in the second curve in red, you can see there is an LMPP. LMPP is short for local maximum power point. And of the two LMPPs, the one on the left side has a higher power. So that is going to be our global maximum power point, or GMPP for short. So similarly, were you to have even more shading, or maybe shading when the radiation levels are even lower, then you could potentially be faced with a situation where your power curve is like the one in black. So there again, you can see that you've got two maximum power points. Obviously, one of them is better in terms of how much power it can get you out of the PV array. That is again going to be the global maximum power point, and it is the inverter's job via the advanced algorithm to settle on that, and which is exactly what it does for you. Now, this is talking about backup power right from the start, but again, this is more geared towards the Gen24 Plus. Okay, and I did tell you that you can purchase the inverter as a regular inverter and then pay for a software upgrade to turn the same hardware into a hybrid inverter. Okay,
Harsha, sorry, I have a
yeah,
couple other questions here.
go ahead.
Wondering what Fronius recommendation is for RSD.
So you could use the existing Fronius rapid shutdown boxes, the Duos and the Quattros, or it is also capable of working with module level power, shutdown, the AP smart systems to be precise.
Great.
Okay, so now this is kind of answering the question that was asked earlier. Harness backup power directly from the sun from the Gen24 with the PV point, which is what I told you earlier. In the event of a power failure, energy is supplied via designated socket with no battery. In the sense, if I were to lose power for the plus again, not the regular one, then if you didn't have a battery, or maybe your battery is dead because you've not had power for quite some time, then you can basically get an AC output through the PV point of the inverter. Okay. Now, a greater flexibility is basically, we've got two MPPTs. So just like the previous inverters, the current capacity of each MPPT is a little different because we have, what should I say? In the past, if you remember the primals or the simals, we used to have, depending on the capacity of the inverter, between 4 and 6 screw terminals, and each of those screw terminals had a current limit on it, which was 15 amperes. So if we don't have screw terminals anymore, the MPPTs, depending on the capacity of the inverter, are either 36 for tracker 1 and 19 for tracker 2, or 36 and 36. And so depending on the short circuit current of the PV module you choose, because now we are all heading towards the ultra high power PV modules, and they tend to have very high short circuit currents, more so if they are bifacial. And so depending on the short circuit currents there, you can either put up 2 strings on tracker 1 and 1 string on tracker 2, or 2 strings on tracker 1 and 2 strings on tracker 2. So you can. Sorry, was that a question?
Nope.
Okay. And so you can play with design on the system in different ways. And again, we always recommend that you use the Fronius string design tool, which we call the Solar Creator. And if you aren't sure or you need support on that, you could always either call it in or join one of our webinars. If not, we will also start making videos so that they can be of use to you, because it's not always necessary that you are installing during our business hours. Now, we were talking about this thing. What should I say? Excuse me, my apologies. The design for the system. So when you are going to be designing for the system, you always have to take into account what is the voltage range of the inverter. Or, when we say the voltage range, you have to keep in mind that the voltage or the MPP voltage and the open circuit voltage of the PV array is a function of temperature. Okay, and so the lower your temperature goes, the higher the open circuit voltage, and similarly, the higher the temperature goes, the lower the open circuit voltage. And you have to pay close attention to this because given our extreme climate, we could literally span temperature ranges from -40 all the way to +40. And so this could put a limit on your system design when it comes to the number of panels you can have in series, because that directly influences the open circuit voltage of the inverter. And this inverter on the DC side can only take a maximum of 600 volts DC. So you may have a third-party simulation tool, but this is where I told you that after you get your string design from the third-party tool, please run that design. We call it a sanity check through the manufacturer's design tool, which is our Solar Creator, to make sure it still is safe for the device and will get you what you think you should get as output from your system. Okay. Now, with regards to the DC to AC ratio, the maximum oversize limit that we allow for without voiding the warranty is 150%, which means on a 10K inverter, 10K AC output, you can put up to 15 kilowatts worth of DC panels as long as you take into account the current and the voltage limitations. Okay, now when it comes to electronics, all electronics will fail. It's not a question of when, it's not a question of if, it's more a question of when. And so this is where how you cool your electronics decides how long your electronics are going to last you. Now, you will see different makes and manufacturers of inverters out in the market. A lot of them use active cooling. Some of them use passive cooling. Fronius strongly believes in active cooling, which means there is an actual ventilating fan. And here you can see that the installer has taken the faceplate off the inverter, and on the top portion of the inverter is where you see that radial design. That's our heatsink, and the little black circle in the middle is your fan. So the fan draws air in and it forces it across the fins of the heatsink, thereby keeping it cool. So the cooler you keep your inverter running, the longer it works for you with better performance and fewer issues on it. So always make sure that you do not choke your inverter and site the inverter in areas where you can count on it being cool. So this is just to give you an idea, like it gives you, I don't know if it's rendering as well, but it is supposed to show you the airflow. So you can see that the fan draws in cool air from the front and it vents it via the fins. So the exhausts are on all four sides. So when you are siting your inverter, you want to make sure that you're not siting it so close to surfaces so as to basically, prevent, I mean, in this case, it's going to vent anyways, unless you actually got something right up flush on all four sides. So, but the idea being that the cooler you keep your system running, the better it performs for you. And really, there is nothing that you can as such maintain on the inverter itself. Most of your maintenance should be geared towards ensuring the insulation integrity on the DC side of the array. Or the DC side of the inverter, which is basically the array. Okay, now in terms of energy management, so I don't know if you are aware, if you have used the Fronius data manager, you will see that there are multiple IOs, as we call it, inputs and outputs. So if you have other smart appliances in the house where you are going to be installing the inverter and they are, what should I say, smart grid ready, you could tie that into the IOs of the inverter to incorporate that into an energy management scheme. Just to give you an example, what I mean by that is, depending on which area you are in, or maybe probably even which country you are, you will realize that energy could be very expensive, and utilities typically are not interested in buying energy back from you because their job is to sell you energy. Now, in places like that, if you are making a lot of electricity and you're not really getting a good rate when you sell it back to the utility company, you might as well game the system through the energy management feature such that you can turn on different appliances at home which can use that energy, because the same energy, just to give you an example, if let's assume that I'm going to run a washer dryer, I stay in Mississauga, we've got time of use pricing, so you tend to pay higher if you use electricity from 7 a.m. to 7 p.m. and lower from 7 p.m. to 7 a.m. overnight hours basically. So let's assume that Mississauga Hydro, that's not the name, fictitious by the way, is not interested in buying energy from me. So when I buy from them during the peak hours, 7 a.m. to 7 p.m., I would pay them 14 cents a kilowatt hour. Whereas assuming Mississauga Hydro is not interested in buying energy back from me, they'll say that during these hours, if you sell me energy, not buy, sell me energy, I'll buy it from you for 2 cents a kilowatt hour. So that really isn't making much sense to me. So instead of selling them the energy, I'd rather game the system such that I can have different appliances at home run, because if I were to run those appliances when the energy is being produced by the inverter, it costs me 2 cents a kilowatt hour to run that appliance. Whereas if I try to run that appliance in the evening when I'm back home from work, then it's going to cost me 7. So I make a saving of 5 cents a kilowatt hour were I to run that unit in the afternoon hours when I don't really get paid much by the hydro company for selling energy back to them. This is a specific case, just to give you an example, but these are the sorts of energy management applications or functions that you can have via the inverter, because it's already built in and available as a feature on the inverter. You just have to make sure that whatever appliances you want to run or you hope to run are smart grid capable. So this is just an extension of the same thing. So I give you an example of a washer dryer, except you could use it to charge your car if you want, or if you've got a HVAC unit, you could overcool your house so that you don't need to cool it as much only during the overnight hours where you might be spending more. Or you could run your washer dryer or any other appliance like that, or maybe you can even use the energy from the inverter to overheat your water. So basically you're using your hot water heater as a dump load. So you could do that via the existing inverter itself, because all of those are functions that are built into it. Like I mentioned earlier, it's just that the appliance that you intend to use it with should be smart grid capable. All right. Outside of this, we've got different communication options on the inverter. So you can have a LAN connection via hardwired connection or a wireless connection. If you want advanced features from the inverter, we've got 6 digital IOs, which are basically short for inputs and outputs. We've got Modbus features on the inverter. You can do both Modbus RTU and TCP. If you want to pull data off the device, we've also got the solar API. That's pretty much what I had planned. If you have any questions, I'm open to that.
Thanks, Harsha. I don't see anything else. Anybody, any questions out there while we have Harsha with us? Okay, so I'm not seeing any additional questions, so thank you, Harsha. I really appreciate you. Oh, here we go. Where are these to be manufactured?
These are manufactured in Austria, Central Europe.
Austria, okay. And just to confirm, there will be 2 inverter options. Yes, we had mentioned that earlier. SB certs. So my understanding is these are all SB certified, Harsha, correct?
These are all UL 1741 SB certified.
And then max oversizing on these units, I think we heard 150% oversizing, depending.
Correct. Yeah.
Okay. And when will they be available?
They would be available starting July.
July. Would there be options for 3-phase? Will the SIMOs still be around?
So the existing ones will be around as long as you do not need an SB on them. But we are simultaneously working on bringing the next version of the 3-phase inverters into our markets. I don't yet have a date on it. The hope is that it will be here 2025. But okay. I'm not promising anything.
Sure. To confirm, all the new Gen24 are SunSpec integrated?
They are, but we are currently working through the certification. The certification got delayed, but it will be out and they are SunSpec, yes. But for now, we've taken it off simply because the certification, we've not gone through with it in the sense it's still in the works.
Okay. Will Fronius be selling the BYD batteries to pair with them?
Likely not, but I do not currently have too much information on that, but I can check on that and get back to you.
Okay. For the Gen24 Plus backup, non-battery design, do you have an SLD to show the wiring of essential loads in this scenario that you can share?
I don't have an SLE, but I can get back to you with some, technical information on it. But please be aware that the full capacity of the inverter is not going to be available via the backup on the PV point. It's only a part of it.
Okay. Which batteries will be UL 9540?
It is to be the BYD because for now the compatibility is with the BYD. We are working on trying to get more than just BYD on it.
Okay. Is derating possible?
You mean like how you to reduce the capacity of the inverter, the output?
Correct.
Yes.
Okay. Will the pricing be less, the same, or more comparable to the Primo? We haven't quite seen that yet, Nick. We'll get that out to people here very shortly, though.
Mm-hmm.
Any additional questions? Okay, well, if you do have additional questions, please reach out to your BayWa rep. We have a great relationship with Fronius. Harsha is always available as well. Thank you, Harsha. Really appreciate you educating us here on the new product. Just a couple of things before we go. If you're not using our web shop, we'd appreciate if you sign up for it. You can find all the specs, pricing, inventory levels, install manuals, see your orders, pay your orders on there. It's a very powerful tool. So many of you are using it now. We'd like to see everybody using it. So just a friendly reminder, this was recorded. It'll come out very shortly on our YouTube channel as well in our newsletter. And once again, thank you everybody for taking the time to be with us. And thank you, Fronius and Harsha. Really appreciate the support.
Thanks, Matt. Thanks for having us.
Okay. Thank you, everyone.
Thanks. Bye-bye.